Hey there, good evening, and welcome to the Scientific Adventures of Beardman. Today we're going to begin our unit on energy, and strangely enough, we're going to begin our unit on energy by talking about work. Well, we've just finished going through a unit where we looked at an idea called impulse, which was a force pushing on something for a certain amount of time. Well, and that change in impulse caused a change in momentum. If you had 18 Newton seconds of impulse, you got 18 Newton seconds or kilogram meters per second of momentum change. Well, we got another way we can look at a force acting on something, and that is when a force pushes on something over a distance. So instead of a force pushing for the amount of time it pushes, we could talk about a force and the amount of distance that it's pushing. Okay, so over the course of 1 meter, it pushes on an object. And those two numbers multiplied together give us work. So we push with a force of 1,000 newtons. We push with that force for a distance of 2 meters. Okay. And we multiply the two numbers together, 1,000 newtons times 2 meters, and we see that we did 2,000 Newton meters of work. Well, now we have a special unit for a Newton meter. A Newton meter is called a joule. Okay, and a joule is a unit we'll use quite a bit, and that's why we don't just leave it as Newton times meters, like we did with impulse, which was Newton second, but a Newton meter is now a joule. You can see that on your California reference sheet if you take a look at that down in the bottom left corner. All right, a couple things about the force though, because it has to be the force pushing over a distance. That means that the force has to be causing that motion over that distance. So if I was pushing this way on something that was moving along, if it was moving along at constant speed, I'm not putting any force on it in that direction. The only force I'm doing is counteracting gravity. And so that would be a situation where there would be no work done because I'm not providing a force that's causing the object to move. Okay? But if we push on something over a distance and we're pushing in the same direction that the object is moving, then we have work being done. Okay? So if somebody is carrying something across the room, it's the most common example you'll see. They're carrying it across the room. That means they're pushing up. They're moving at a constant velocity, so there's no forward force because air resistance is negligible, and so there's really no forward force. And so as we carry that, there's no work being done. Now, on the other hand, if you slide something along the floor, there's significant friction, which means you're pushing a force in the direction that the object is moving. Okay. As we get farther, we'll talk about more commonly, we'll talk about pushing an object with no friction, where that force will then give the object energy. But that's for a later lesson. So if the force is perpendicular to the direction of the motion, then there is no work being done. But if the force and the direction of motion are in the same direction, then we can multiply those two numbers, the force times the distance, and get the work being done. The other thing you should be familiar with work is that besides pushing something sideways with usually friction as a background for that, or the object is accelerating, we often will talk about lifting something against gravity. Okay, so if we take a 700 Newton cat, okay, that's a pretty big cat, 700 Newton cat, and we lift it, well, if we're lifting at constant velocity, then that means our force up equals the force down on the cat. And so if gravity's pulling on it because it has a weight of 700 newtons, then I am lifting up with a force of 700 newtons. And so then you can use the height, which is the distance that I lift it in the same direction that I'm pushing, and multiply the force, which is equal to the weight of the object, the force times the height, the distance, and that's a work that's being done. The force times the distance. That's it. We'll see you next time. Go out and do some work, and we'll see you next time on Scientific Adventures of Beardman. Bye-bye.